All right, after this last logarithm test, the scores were horrendous. So we have an enhancement coming up. We're gonna go through 5 problems and then we're gonna get you the enhancement. So follow along, we're gonna do this quickly, but we're gonna identify the mistakes everybody's been making and then what properties are needed and how to solve these 5 problems. Here we go, first up. Biggest mistake I saw in the test. First off, you drop the logs. You cannot drop logarithms until it's one-on-one with the same base. We have 2 on one side, the other side doesn't even have any logs, so you cannot drop them right away. Second mistake, I don't know where you found this. No one was ever showed this in class, but right here, you know what I saw people do? They took log 5. In their calculator, log 5, boom, enter, and then they multiplied it by x minus 2. Never have we ever done that, so stop doing that. If, this is the first property you need, if you are subtracting logarithms, you put those together through division. So the first step would be log base 5 of 3 over x minus 2 equals 2. Some of you get here and you're like, okay, now I drop the log. No, you can only drop the log if it's 1 on 1. Say it with me now. 1 on 1. Okay, good. So when you have one logarithm, you put it into exponential form. Exponential form, the thing we learned day 1 of logarithms. Remember my song? Do, 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 do. You get 3 over x minus 2 equals 5 squared. Now it's an algebra 1 problem. 5 squared is just 25. My variable piece is in the denominator, so to get it out, I must multiply, leaving me with 3 equals 25x minus 50. Oh, it gets real easy from here. 53 equals 25x. Divide both sides by 25, and x equals 53 over 25. Done. Here's problem number 1. So what did you need to solve that one? You had to know that when you subtract logarithms, you combine through division, and then if you have a 1 log statement to solve, you must put it into exponential form. Next one. Ooh, they all have logarithms. Let's drop them. No! Stop doing that. That is a 2 on 1. That's rude and inappropriate. So we have to wait till it's 1 on 1 before we can drop the logs. We're adding. So the first property up. When you add logarithms, you must, let's think, if we subtract it, we divide it, and when we add, we multiply. One of the first properties we learned. So I'm going to combine these, and it becomes log base 3 of x squared minus 2x equals log base 3 of 8. Hey, look at what we have. 1 on 1. Now you're allowed to drop logarithms. This is the only time you're allowed to drop logarithms. You guys just drop them all the time. It's inappropriate to drop your logs whenever you want. There's a time and a place. So now when it's 1 on 1, we're allowed to. Leaving us with a quadratic, which everyone should be able to solve. Get equal to 0. And easy peasy factoring here. Factors of c that add to b, that's going to be a -4 and a +2. So my 2 answers are 4 and -2. But wait, did you check your answers? You're not allowed for any of these quantities to be a 0 or a negative. Let's plug 4 in. We get 4 and 2. Worked out. Plug -2. Oh no! -2 did not work, so your only solution here is 4. Okay, 2 down, 3 to go. Stay with me. Where are your variables? In the exponent, kind of gave it away. The only time we take the exponent into the front is if there's a logarithm involved. That's the last property we haven't talked about. But I don't see a logarithm. Do something about it. If you take the log of each side, it's fair. And now my x minus 3 can come out, and I'm left with log 7. My 2x plus 5 can come out front, and I'm left with log 3. Now there's a couple ways to solve from here, but what I saw in the test was almost all of you found the decimal early and then solved with algebra 1. That's what I will do as well. So for log 7, the first decimal that we round, if we round appropriately to the nearest 10,000th, we'll get x minus 3 times 0.8451 equals 2x plus 5 times 0.4771. If you are not coming up with that decimal at this step, you're punching into your calculator incorrectly, or you don't know how to round. Both are issues we need to resolve. Distribute and solve, algebra 1 from here. So I'm left with 0.8451x minus 2.5353 equals 0.9542x plus 2.3855. All right, all I'm going to do here before this next step, I'm going to bring all my numbers to this side and my variables to that side. That's it. So I'm going to subtract 2.3855, leaving me with negative 4.9208 equals, I subtract the 0.8451, 0.1091x. Last step, divide by 0.1091. Divide by 0.1091. X is approximately negative 45.1036. So what do we need to solve that one? When the variable is in the exponent, we take the log of both sides, which creates a scenario where the exponent can come out front. We found our decimal early and solved algebra 1. Very simple. Speaking of simple, last two involve natural log and e. You guys really struggle with this, and it should have been the most basic ones. Both of them start with the same principle. We need to isolate them. We need to isolate the natural log or isolate the e. So these first two steps should be basic algebra. I subtract the 5, giving me negative 15. It's not isolated yet. I divide by 3, giving me positive 5. Okay, we actually have already done a problem like this. A natural log is still a logarithm. So as everybody see, we have a statement where we have one logarithm. One logarithm like this one. What do? We put it in an exponential form. Do the same. But it's natural log. What does that mean? It means it's log base e. So if you bring the e over, now we have 2x equals e to the 5th. That is putting a natural log statement into exponential form. Calculator time. Plug e to the 5th into your calculator and divide it by 2. Final answer, you should come up with approximately 74.2066. Easy problems if you know what you're doing. Last one. E. Okay, get it isolated. Pick up the blue. Easy steps here. I'm going to subtract the 3. I'm left with 4e to the 3x equals 3. It's not isolated yet. Divide by 4. E to the 3x equals 3/4. Okay, all right, get ready. When you have an e, remember we still want to take a logarithm at times to bring that exponent out front, but instead of taking a normal logarithm, I'm going to use a very nice principle here. If I take the natural log of each side, this 3x will come out front, and I'm left with times natural log of e. But if you remember, natural log is log base e. So all of a sudden we have log base e of e. Hope that doesn't confuse you. This ends up being just 1. So I'm left with 3x equals natural log of 4. Very convenient. Calculator time. Divide by 3. X is approximately negative 0.0959. Those are 5 problems that demonstrate all the properties and principles you will need to complete your enhancement, and you should have known before we took our test. Good luck.